Hi, my name is Tamarapalli Venkatramana. I am a third year Electronics and Communication Engineering student at Aditya Institute of Technology and Management Technical. We are here to project a simulation of microwave oven provided by Amatex Information Technology Bangalore and also a internship provided on embedded systems. In this,
Let's see the overview of the internship. In this internship, we did basics of C programming, microcontrollers, introduction to embedded systems, introduction to project requirements or tools used, implementation or demonstration, Disha, working, and conclusion. Our goals of our internship is to understand the C programming, to variant microcontrollers and microprocessors, to understand the prominence of embedded systems, to use the PIC16F877A and MPLAB X IDE, to program the whole microwave oven project, to simulate the project and test all modules. Let's know basics of C programming. C programming is a mid-level programming language known for its efficiency, portability, and flexibility, also referred as the mother of programming languages, a free formatted language used in various specific domains. Programs in C are structured as a series of functions or procedures. Each function can perform specific tasks and can be called from other parts of the programming. This module approach to C programming makes C code organized and easy to maintain. These are the topics we learned in C programming in our internship. And let us know about microcontroller. Microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals in a single chip. In contrast to microprocessor, which are used in personal computers and other devices, microcontrollers are mostly used in embedded systems such as implantable medical devices, automotive engine control systems, and so on. There are different types of microcontrollers. They are 8-bit, 16-bit, 32-bit, ARM, PIC, AVR, FPGA based. And the difference between microprocessors and microcontrollers as shown in this table. First, we show about microprocessor. A microprocessor are widely used in computer system. Various microcontrollers are used in embedded system. In microprocessor, it has only CPU embedded. In microcontroller, it has CPU, a fixed amount of RAM and ROM, and other peripheral all embedded on it. In microprocessor, in case of processor, we have to connect all the components externally, so the circuit becomes large and complex. In microcontroller, the already these components are available, so the small in size. In microprocessor, it consumes more power, where microcontroller it consumes less power. In microprocessor, it has very less internal storage, so it has to rely on external storage. So all memory operations are carried out using memory based external commands, which results in high processing time, whereas in microcontroller it has many registers, so processing time is less. Now let us introduction to embedded systems. Embedded system is an integrated system that is formed as a combination of computer, hardware, and software for a specific function. These many work independently or attached to a larger system to work on a specific functions. These embedded systems can work without human intervention or with little human intervention. There are three main components of embedded system are hardware, software, and firmware. The applications we are seen in embedded systems are digital clock, elevator, oven, washing machine, toys, televisions, digital phones, and so on. Let us know about embedded system structure. The following diagram shows the embedded system structure. In terms of hardware, a basic embedded system would consist of following elements. They are sensors, analog to digital converters, processors, digital to analog converters, actuators. Sensor. A sensor means which converts physical signal sense data into electrical signal. Analog digital converters, which means changes analog electrical signal into digital signal. Processor means a process digital signal and stores them in memory. And digital to analog converters means changes digital data to analog data after processing. Actuators. Functionality of actuator is the output to input what we provide. That means it converts electrical signal into physical signal. Now, introduction to our project. Our project in this internship is microwave oven. Is an electric oven that heats and cooks food by subjecting it to electromagnetic waves. The microwaves are absorbed by water, fats, sugar, and certain other molecules whose consequent vibrations produces heat. The heating thus occurs inside the food without warming the surrounding area, which greatly reduces cooking time. The microwave is a household appliance that has revolutionized modern home kitchen. Microwave ovens are so quick and efficient because they channel heat energy directly to the molecules inside food. There are various modes in microwave oven. The following four modes will be implemented. They are micro mode, convection mode, grill mode, start mode. First one is micro mode. In this mode, the food is cooked in a traditional way. It uses a maximum power of 900 watts and the maximum heat time that we set for cooking is 60 minutes. Second one is grill mode. This mode is simply used for grilling. There are another grill heater placed in a specific location that can provide the grill effect. Convection mode. In this mode, the heat is turned on, the fan is provided within the microwave chamber that circulates air throughout the chamber to give the baking effect to the item placed inside. Last one is start mode. This mode is used to switch on the microwave oven, and by default the time will be set to 30 seconds. In our project, now let us know the project requirements or tools used for this microwave oven project and simulation. The project requirements are knowledge in embedded C, MPLAB X IDE, XC8 Compiler, PIC simulator. In this PIC simulator, we use PIC GNS board and PIC16F877A microcontroller, 16x4 CLCD, tactile switch, matrix keypad, buzzer, cooling fan, and timers. Now let us come to programming. We use embedded C programming. Embedded C is a set of language extensions for the C programming language by the to address common issues that exist between C extensions for different embedded systems. Embedded C programming typically requires non-standard extensions to the C language in order to support enhanced microprocessor feature. C programming. C programming is a possessive native development in nature, independent of hardware architecture, used for desktop applications, OS, and PC memory. Embedded C programming possesses cross development in nature, dependent on hardware architecture, microcontroller, or other devices, used for limited resources like RAM, ROM, and input-output peripherals on embedded controller. Now let us know about PIC-Lab architecture. PIC-Lab is a real-time emulator of development boards with integrated MPLAB X debugger. PIC-Lab supports some PIC microcontrollers. PIC-Lab have integration with MPLAB X Arduino IDE for programming the microcontroller boards. And this diagram shows the PIC-Lab Simulator. In this PIC16Lab, we use PIC genus board and PIC16F877A microcontroller. And this is the PIC16Lab architecture, which shows the pin layout of PIC16F877A pin diagram. It supports GPIO pins and EEPROM, temperature sensors, digital keypad, and other ones. And this is the internal architecture of PIC16F877A. It has totally 5 ports and RAM, address multiplexers, file select register, status register, multiplexer, arithmetic and logic unit, work register, instruction decode and control, program memory, instruction register, program counter, and EEPROM data memory. While coming to the CLCD, means character liquid crystal display, CLCD. CLCD is the most basic form of an electronic display device which is widely used. The main advantage of using a CLCD instead of a 7-segment display and other multi-segment LEDs is that there is no limitation in displaying special and custom characters, animation, and so on. Most importantly, the module can be interfaced much easily, unlike other modules which no complexity in both hardware and software. In PIC16Lab, there are two types of displays. One is 16x2 display and second one is 16x4 display. ASCII characters and some special characters are displayed. Two types of communication modes are used are 4-bit mode and 8-bit mode. CLCD consists of two registers, command register and data register. While coming to the matrix keypad, this is a small compact input device that accepts user inputs and processed by microcontrollers. A matrix keypad is the kind of keypad you see on microwave oven, gas pump, and calculators. It consists of a number of tactile switches arranged in a row and column format. The advantage of a matrix keypad is that the use of it will allow the programmer to reduce the number of pins to be used. And while coming to the buzzer and cooling functions, the buzzer are electric sounding device that generates sounds, typically powered by DC voltage. They can be organized as piezo buzzer and magnetic buzzer. They come in different designs and use as well, and based on that they can produce different sounds. In a magnetic buzzer, the current will be driven through the coil of wire and causes the vibrating disc to be attached to it. The movement of disc would produces the sound and it will return to its original state when there is no current flowing through the coil of wire. The cooling fan in a microwave attempts to dissipate the hotness and create by the stove. This guarantees that it stays at a protected level. However, more seasoned microwaves didn't have cooling fans and rather than highlighted a stirrer fan which has intended to do exactly the same thing. While now coming to the interrupts and ISR. ISR stands for interrupt service routine. First, know about interrupt. An interrupt is a signal to the CPU to immediately begin executing different code that is written to respond to the cause of the interrupt. An interrupt is a communication process that is set up in a microprocessor or a microcontroller in which an internal or external device requests to stop the processing, and these microprocessors and microcontrollers acknowledges the request and attends to the request. Now know about interrupt service routine. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, execute the handling, and then returns a logic interrupt value. A basic example of an ISR can be a routine that handles keyboard events such as pressing or releasing any key. Now coming to the timers. Timer is a clock that controls the sequence of an event while counting in fixed intervals of time. A timer is used for producing precise time delay. The timer is an important application in embedded system. It maintains the timing of an operation in sync with a system clock or an external clock. The PIC16F877A PIC MCU has three timer modules. They are named as timer 0, timer 1 and timer 2. The timer 0 and timer 2 are 8-bit timers, whereas timer 1 is a 16-bit timer. These modules help to perform various timers and counters or PWM generation. PWM stands for pulse width modulation. And now implement or demonstrate the project in MPLAB X IDE. To implement of microwave oven project is done by using PIC16Lab and MPLAB X IDE. The steps to follow: we initialize the project. Go to MPLAB X IDE and create new microchip embedded standalone project. Next, select families. Mid-range 8-bit MCU and press PIC16F877A and select finish. Now compiler toolchains is XC8 Compiler and next. Project name microwave oven, project location folder, finish. Firstly, we create two main folders. First one is main header folders and main source folders. Create main.c file in source file. Create main.h file in header file. Now let's come to coding section for this project. We have mainly 5 types. There are CLCD, matrix keypad, ISR, timers and main. The given code is a header file is clcd.h for controlling a character LCD using a PIC microcontroller. It defines macros and functions prototypes required to interface with LCD modules. In this, there are totally 8 sections are there. They are header guard, defining system clock frequency, LCD control and data port configuration, defining modes and constants, and LCD addressing, rows and column positioning, LCD initialization and commands, and special characters and function prototypes. This header file defines macros and function prototypes for interfacing a character LCD with a PIC microcontroller in 4-bit mode. And second one is main.h. This defines for microwave oven controller system using a PIC microcontroller. It includes essential libraries, macros, and function prototypes for handling the system's operation, including different cooking modes, a keypad interface, timers, and peripheral control. It has mainly 7 types, 7 module structures. First one is header guard, second one is include require libraries, third one is defining operating modes, fourth one is resting options, fifth one is peripheral controls, sixth one is general macros, seventh one is function prototypes, and this header file defines modes of operation for the microwave, peripheral control macros, function prototypes for core operation. This file is a crucial for implementing a microwave oven control system using a PIC controller. Now coming to the matrix header file. For interfacing a 16 into 4 matrix keypad is with a PIC microcontroller. It defines macros and function prototypes needed for keypad scanning and reading key presses. It has also same. First one is header guards, second one is defining keypad ports, third one is defining row pins, fourth one is defining column pins, and defining high-low logic states for the rows and function prototypes. This header file is designed for 3 into 4 matrix keypad using port B columns and port D rows. The function defined in another .c file will allow keypad scanning, detecting key presses, and returning the pressed key value. This setup is typically used for microwaves, security system, and calculators. And fourth one is timers.h for configuring timers in a PIC microcontroller. It provides functions prototypes for timer 0 and timer 2 initialization, which will be implemented in the corresponding .c file. And it has also consists of header codes, function prototypes, and of header files. And this header file declares two timer initialization functions, that is timer 0 and timer 2. The actual implementation will be written in separate source file. Okay, timer 0 might be used for delays or event counting, and timer 2 used for pulse width modulation generation or precise time intervals. Now, coming to C programming is a LCD driver for interfacing a character LCD with a microcontroller in 4-bit mode. The functions which allows sending commands and data to the LCD, displaying characters, and initializing the display. It consists of include header files, writing data to LCD, and sending the upper nibble high 4 bits and sending the lower nibble low 4 bits. Finally, delay, and with initializing the LCD controller and initializing the LCD with data ports as outputs and displaying a single characters and displaying a string on it. This LCD drives allows initializing the LCD in 4-bit mode, sending commands to configure display settings, displaying single characters or full strings on the LCD. This is essential for applications like microwave ovens to display the output. And next one, interrupt service routine for timer 2 in a PIC microcontroller. This interrupt service routine handles timer 2 interrupts in a PIC controller. It keeps track of times, seconds and minutes, decrementing them every second. It include required header files, external variables, interrupt service routine definition, and declare a static row counter and check timers interrupters and increment counter and check for 1 second, updated time, clearing the interrupts, and optional is toggling on LED. The triggering by timer 2 interrupt counts 1 second after 1250 timer 2 overflows, decrement seconds and minutes variables every second, clears timer 2 interrupt flag to handle the next interrupt. This ISR can be used for countdown timers, digital clocks, or of microwave oven. And microwave controls embedded C. This embedded C programming implements a microwave oven control using PIC controllers. It includes features like menu selection, time, temperature, door status, buzzer, fan control, timer based countdown using interrupts. And this includes header files and configuration, global variables, initialization functions, and these initialization functions are purpose is based on LCD and keypad initialization, fan and buzzer setup, timer 2 initialization, interrupt enable, door sensor configuration, and main function, menu handling and mode selections. It handles a key inputs to set cooking mode, updates operation flag to indicate the select mode, clears the screen and prints appropriate messages, and time display and controllers handling pause and stop, door status handling, times display on LCD. This is contains in main source file. The features of main source file is power on, displaying load screen, and select microwave, grill, convection or start modes. User inputs cooking time and temperature, pauses cooking when the door is open, turns on during cooking, off otherwise, keeps track of seconds and update the LCD. And this matrix source keypad This matrix keypad code source file is responsible for initializing and reading input from a 4x3 matrix keypad using general purpose input output pins on a microcontroller. It includes header files and functions purpose initializing the general input output pins for keypad operations and scans the keypad for a key press and returns the corresponding key values and returns the pressed key based on specified mode. In this initiate matrix keypad configure columns as inputs and rows as outputs, enable pull up resistors, sets all rows to high initially, and scan keypad scans the keypad row by row. If the key is pressed, it turns to corresponding value. Read matrix keypad mode. Level mode continuously detects key presses, and state mode registers each key press only once. And keypad layout mapping. And while coming to the source file for timer is this function initialize timer 2 in a microcontroller, likely a PIC microcontroller, by configuring in prescaler settings, preload values and enabling interrupts. Okay, this include function definitions, selecting the prescalers and selecting the timer 2 period and enabling timer 2 interrupts, turning off timer 2 initially. And for summary, for source file for timers, it sets prescale to 30 seconds and sets timer to overflow value to 250 and enables timer to interrupt and keeps timer to off until explicitly started. Let's simulate this project in PICSIM-LAB. Now open PICSIM-LAB and load .xe file from our debugging. After the debugging, and select PIC genus board and select PIC16F877A microcontroller. When we power on message screen, it shows the output powering on, and third line is microwave oven. Second one is cooking mode screen. The output is the cooking mode screen will contain following cooking modes display: macro, grill, convection and start. The key 1 is used to select macro mode, key 2 for grill mode, key 3 for convection mode, key 4 for start mode. While coming to press key 1, it will use as macro mode. The output will display as power equal to 900 watts. After 3 seconds, it displays set time. In this, we select minutes and seconds. Let us consider 11 seconds and press enter while hash. While enter into the macro mode, it slowly decrement the time, and after the 11 seconds the fan is turned off, and we have the following keys is used for resume and increment for key 4 is used, and pause for key 5 is used, and to stop 6 is used for. And after the time is end, the macro mode is ended and come back to home. And second, select grill mode. The output should print as set time, while it is also same like as macro mode, but it doesn't consist of 900 watts. And third one is convection mode. This is temperature based. When we set the temperature, it set according to that temperature to set up the environment for that temperature and decrease up to the temperature. And now, and 30 seconds timer is on, and after the time up is end, the convection mode is also ended. And last one is start. The start has mode will microwave with defaultly 30 seconds time. Remaining cooking time minutes and seconds is printed on line 1. Key 4 is used to resume or increment by
30 seconds. Key 5 is used to pause cooking process. Key 6 is used to stop cooking process. This is for simulation for this project.